Hello guys. This is another day. Good morning, good afternoon, good evening. Welcome to Legends in Learning digital class. Okay, so today is another day. We are coming to look at a very good topic to explain in science. That's for junior high school 2. Okay, junior high school form 2 science. So we'll be looking at diversity of matter, and under diversity of matter, we'll look at mixtures. Okay, look at mixtures. Firstly, we'll look at what mixtures are. What do you know about mixtures? So we say mixtures are the physical combination of two or more substances. So when we take any substance at all, it can be any of the three states of matter, can be solid, liquid, gas, and we mix them together. We are making a mixture. Okay, we are making a mixture. So when we are making a mixture, no chemical reaction occurs. The substance that form the mixture can usually be separated back into their original form or state. So that makes them mixtures. Okay, so let's look at some examples. Some examples of mixtures. We can have water and oil. Okay, and we can have the soil, the crude oil, alloys. We all know alloys. Alloys can be a mixture of metals. Okay, mixture of reactive metals. Okay, and crude oil can contain petrol, kerosene, petroleum gas, and okay. So this is a form of mixture. This one here is a form of mixture. You can see um, it's containing many colors of things. Okay, we have red, blue, yellow, white, and we have purple over there. Okay, so let's move on. How can mixtures be grouped? Okay, so we have two groups of mixture. Let me say we have two groups of mixture, which is homogeneous and heterogeneous. Okay, so as their first name denotes, homo means the same and hetero means different. Okay, homo means the same, hetero means different. So homo means homogeneous mixture is a type of mixture which the composition is uniform. So when we are mixing something, okay, we are making a mixture, and then their composition becomes uniform. We said it's a homogeneous mixture, and then heterogeneous mixture is a type of mixture in which the components can easily be identified. Okay, so we can have them in layers. Mostly heterogeneous mixtures can come in layers. We can have 2 layers, 3 layers. That means they have not been uniformly mixed. Okay, so they can have two or more phases that is present in the mixture. So this is denoting a heterogeneous mixture, and then and homogeneous mixture over here. Okay, so you can find them over there. So let's move on. Okay, so these are some kind of mixtures and then their compositions. Okay, so we have many different kind of mixtures, or we have many different mixtures we can talk about. Okay, we can talk about seawater. Seawater is a mixture. If you don't know, seawater is a mixture. Blood is a mixture. Soil, crude oil. So we take blood. Blood has many compositions. It's consists of red blood cells, white blood cells, the platelets, the salt, water, hormones, and some proteins, and even glucose as well. And when we take the soil also contains humus, rock particles, living organisms like the worms. Okay, and then when we take the crude oil has compositions as well, which is the gas oil, the kerosene, the bitumen, liquefied petroleum gas, gasoline. Okay, so this is a typical example of blood. You can see the platelets, red blood cell. Okay, and this is an example of the soil, which is composition of the soil. Okay, and this is a crude oil. So that's just by the way examples. Okay, let's move on. So next on our list will be the types of mixtures. Okay, the types of mixtures. So when we look at the types of mixtures, first on my list we have solid mixtures. Okay, solid mixtures. So when we're talking about types of mixtures, can be like we are matching the three states of matters to each other. So when we take the three states of matter, we can match the first to the second, the first to the third, the second to the third, and the third to the first, the third to the second, like that, in that way. Okay, so it's not difficult. First on my list we have solid mixtures. So when we talk about solid mixtures, it involves two solid substances. Okay, so it involves two solid substances. So example can be steel. Steel is um, an alloy. Okay, so we have copper alloys as well. So bronze and brasses, when they combine, they create a copper alloy. Okay, and then steel is a combination of two solid particles or metals. Okay, and we have concrete. Concrete also is combination of the gravels, the sand. You know that, yes. So second on my list is solid liquid mixture. Solid liquid mixture. So when we take solid liquid mixture, can involve a solid and a liquid substance. So it's not easy to it's not difficult to explain them, because their names explain itself. Okay, so when we take solid liquid mixture, it means we are combining a solid and a liquid together to form a mixture. Do you get it? Okay, so solid liquid mixture is a mixture that involves solid substance and a liquid substance. Let's look at some example. We have sugar and water. Yes, sugar is a solid, water is a liquid. And we have seawater. Seawater also is a combination of salt and water. That forms the seawater, like the oceans we know. Okay, and mud. Mud also is a combination of the sand and the water. Okay, so when it rains, it wets the soil, which forms mud. That's the combination of the rainwater and the soil. That's the soil becoming the solid, and then the rainwater is the liquid. So we have latex paints as well. Third on our list, we have solid gas mixture. Okay, very simple to denote. So that's a solid and a gas substance, or a gaseous substance. So solid gas mixture is a mixture of a solid substance and a gaseous substance, or a gas substance. Example is smoke. Okay, example is smoke. And we have dust particles as well. So when we're having dust particles in the atmosphere, it mixes with the atmospheric air. That forms a solid gas mixture. Okay, so let's move on. The continuation of our types of mixtures, there are many, so we have to finish them. Okay, this is a liquid mixture. A liquid mixture, as the name denotes, it's two liquids. Okay, so it involves two liquids. Example is water and alcohol. Water and alcohol, and we have kerosene and oil. We have vinegar. That's vinegar is a combination of acetic acid in water. Okay, acetic acid in water, which gives us a vinegar. And antifreeze. Antifreeze. I think this is new for you, but antifreeze is when we combine water and ethylene glycol. Okay, ethylene glycol gives us antifreeze. And we have liquid gas mixture. Okay, liquid gas mixture, as the name denotes, is a liquid and a gaseous substance. So it's a mixture of liquid and gas. Example is our fizzy drinks we take in. Okay, or some will say carbonated drinks. So when we open them, the pop sound we hear is the escape of the gas. So the liquid is there, and then the gas is on top to preserve it. Okay, so when we open it, the pop sound we hear is when the gas is escaping from the container. Okay, so from here we'll go for a short break. So let's look at our last type of mixture. That's a gas-gas mixture. A gas-gas mixture is a mixture of gases, as the name denotes. Gas-gas is a mixture of gases. So let's look at example. Example is the air. The air has its components. That has the carbon dioxide, oxygen, nitrogen, vapor, water vapor, and the inert gases, and all of them has their percentages they cover in the atmosphere. Okay, so this is a very good example on gas-gas mixtures. So we'll go on a short break from here, and we'll come back. So stay tuned. Okay, so welcome back to my channel. Okay, so let's continue. We ended on the continuation of our types of mixes. So we will continue from solutes, solvents, and solution. I think we've all heard about it. If you've not heard about it, don't worry. I will explain it for you to understand it better. Okay, so we're talking about solutes, solvents, and solution. So this three uh, is all the basis of mixtures. Okay, so the mixtures are formed under these three. Okay, so when we mix the first two, that's solvent and solute, it forms solution, which the solution is known as the mixture. Okay, so let's look at the definition of a solute. A solute is any substance that dissolves in a solvent. Okay, it dissolves in a solvent. Let's look at the definition of a solvent. A solvent is any substance, be it liquid or gas, that dissolves a solute. So the solute is the solid, okay, and then the solvent is the liquid. So for example, we can have seawater, or let me say salt and water, okay. So the salt becomes our solute, and the water becomes our solvent, okay. So solute dissolves in solvent, so the salt dissolves in water, and then when we take the solvent dissolves a solute, so the water dissolves the salt. So don't confuse. It's a little bit confusing for some students, so that's why I'm emphasizing on this. The solute is a substance that dissolves in a solvent, and the solvent is a substance that dissolves a solute. Let's look at the definition of a solution. The solution is the uniform or homogeneous mixture of two or more substances. Okay, so when we talk about homogeneous mixture, we've already said it. We'll explain the homogeneous mixture already. So homo means the same or uniform. Okay, so it's a uniform or homogeneous mixture of two or more substances. So this gives us how we should look at what I said earlier. So solute plus solvent gives us solution, and the solution is the mixture. Okay, so this is an image example of it. So you can see a solvent in a glass and then the solute, and when we mix them, it forms a uniform mixture over there, which is the color red. Okay, let's move on. We'll be talking about soluble and insoluble substances. So when we talk about soluble and insoluble substances, the name, or let me say the sentences itself, gives a clue, okay, when something is soluble and when something is insoluble. So let's quickly look at soluble substances, okay. So soluble substances, they are substances which dissolves completely in a solvent, okay. They dissolve completely without a trace in a solvent. So for example, we can have when sugar is put in water, okay, it dissolves completely in the water. And then when grease dissolves in kerosene, dissolves completely, uniformly in the water. Okay, and all these things can be separated back, so don't worry. We will be looking at suspensions and the separation of mixtures in our next lecture. Okay, so you understand and you appreciate mixtures. Let's look at insoluble substances. So insoluble substances, these are substances which do not dissolve in a particular solvent. Okay, they do not dissolve in a particular solvent. So for example, you can have grease. Grease cannot dissolve in water, but it can dissolve in kerosene. So that makes grease insoluble substances or insoluble substance in water. Okay, so mostly some of the insoluble substances can be soluble and cannot be soluble. So that means all substances can have their soluble behavior and insoluble behavior in some cases. Okay, so when we are having a solvent and we bring another substance and we put it in the solvent and doesn't dissolve, it makes it insoluble to that solvent. But when we break a different solvent and we put it in it and it dissolves, it makes it soluble to that particular solvent. So it depends on how you use it. Okay, so let's look at examples of solvents that are used in our homes and then the substances they can dissolve. So when we look at water, water can dissolve many things. Okay, so salt can be soluble in water, sugar is soluble in water, tea is soluble in water, coffee will take the milk, alcohol, starch, emulsion, paint, fruit juice, and milk are all soluble in water. When we take kerosene as a solvent, kerosene can dissolve coal tar. Okay, so coal tar can be a soluble substance in kerosene. And then grease, fat, and then wax all can be soluble substances when placed in kerosene. Let's take turpentine. Turpentine can dissolve oil paint or can mix with oil paint. So when we put oil paint in turpentine, it can be a soluble substance in turpentine. Let's take petrol. So grease, fat, glue, wax, candle, and oil can all be termed as soluble substances in petrol. When we take alcohol, we take plant pigments, okay, that we know as dyes. Example like the chlorophyll. When we place it in the alcohol, it can be soluble in the alcohol. So that makes it a soluble substance in alcohol as a solvent, okay. When we take benzene, rubber or the latex can be a soluble substance in benzene. Okay, that's a quick examples we've looked about. Let's look at forms of solutions. So we talked about solutions earlier. We said solutions is when we have a solvent and a solute coming together. They form a solution. Okay, so let's look at forms of solution. How many forms of solution or how differently can this combination of the solute and the solvent appear? Okay, so the first on my list we have concentrated solution. Concentrated solution is a solution that contains more solute dissolved in a relatively small amount of solvent. So when we're having more of the solid, or yes, more of the solid, okay, dissolving in a little amount of the solvent. So example, we have 10 cubes of sugar dissolving in 100 centimeter cube of water. You can look at it, very, very small amount of water, and then the the solute is huge, okay, but it can dissolve it. Do you understand? It can dissolve it, but why we term it as concentrated is because the solute is many, is too much in the solvent, okay. um, when we take dilute solution, this is a second on dilute solution. Dilute solution is a solution that contains less solute dissolved in a solvent. So when you're having a less solute dissolving in a relatively huge amount of solvent, example is 2 cubes of sugar dissolved in 100 centimeter cube of water. Okay, so we term this as dilute solution. So dilute solutions having more of the solvent as compared to the solute. But concentrated solution is having, let me say, relatively equal or solvent more than the solute. Okay, so let's continue. The third on our list, we have aqueous solution. Aqueous solution. Aqueous solution is a solution whose solvent for dissolution is water. So aqueous solution has a solvent to be water alone, no other solvents attached. So solvents can be grouped into liquids, and liquid water forms under liquid. So aqueous solution is formed when we use water as a solvent for dissolution. Example can be salt dissolving in water. That's the salt water. Okay. The next is miscible solutions. Miscible solutions. Okay. So a miscible solution can be termed as that's a solution that dissolves well in each other. So when we have two or more liquid substances and they can dissolve well in each other, we call them miscible solutions. Okay. So for example, we have water and alcohol. We can mix water and alcohol together to have a well mixed solution. Okay, and we can mix petrol and kerosene and then turpentine to have a well mixed solution. We can have oil, paint, and petrol, which will give us a very uniform mixture. Okay, the next is immiscible solutions. Immiscible solutions, they are termed as solutions which form by two or more liquids that do not dissolve in each other. So miscible dissolves in each other, immiscible cannot dissolve in each other. So this is a very rare situation, real life situation. Okay, so for example, we can take the oil and water. So when we take oil and cooking oil and water, they can never mix. Why? Because different densities. The oil will be at the top, the water will come at the down, and then oil, paint, and water. Okay, the oil paint will go at the down, the water will be at the top. It can never mix. It can never mix. Okay, so we move on to our next, which is the factors that affect the rates at which a solute dissolves in a solvent. So what are the factors which affect the rate at which a solute dissolves in a solvent? So when we place a solute in a solvent, how fast or how slow can it dissolve? And what are the things that are affecting it? Okay, so the rate at which a solute dissolves in a solvent can be speeded up by heating the mixture. Okay, so when we heat the mixture, it increases the temperature. For example, when a spoonful of Milo, okay, dissolves faster in hot water than in cold water. Yes, that's an example, and you can try it and you see it works. So when we are having we are making our tea at home. Okay, so have a cup full of cold water and a cup full of hot water, and try to make your tea in both of them, and look at which of them will speed up in dissolving the Milo and the milk and then the sugar you pour in it faster. You can see that the one which is having a higher temperature, that's the boiled water, will dissolve it faster than the cold water. The second one, we have stirring or shaking the mixture. So when we stir the mixture, it can increase the rate of dissolution. Okay, it can increase the rate of dissolution. That's the rate at which the solute dissolves in the solvent. So when I'm having my sugar, okay, let me say I'm making my tea. Okay, I poured my milk, my Milo, and I poured my sugar. So if I don't stir it, you see the sugar, some of the particles can be settled under the tea. So if I don't stir it, it won't dissolve faster as I want it. Maybe I'm rushing to my office and I need to hurry up, so I'm making a tea. So how can I make the sugar dissolve very faster than the normal time? So I have to stir it. I have to shake it very well for it to dissolve. So shaking and stirring the mixture brings about equal distribution of solutes in the solvent, and this causes them to dissolve very, very faster. Okay, so the third is using solutes of smaller size. Okay, so when I'm using solutes of smaller size, it's a real life situation. You know that it will dissolve very faster. So for instance, when I take my a pinch of salt, when I'm saying a pinch of sugar, and I put it in the water, okay, and I take a cube of sugar and I put it in the water, which of them dissolves faster? Is the pinch of salt or sugar. Okay, why? Because it's having smaller size. Okay, so they dissolve faster in the solute than when they are big. For example, when we have granulated sugar, dissolves faster in water than the cube of sugar or the cube form of sugar. Okay, so let's look at importance of shaking or stirring some mixtures well before they are used. We said some already, stirring and shaking the mixture, how important it is. So it can increase the rate of dissolution. Okay, the mixtures need to be shaken or stirred so that the solute will be equally distributed and dissolve faster in the solute, as we said earlier. So it needs faster dissolutions. Okay, the second is it explains why emulsion paints and liquid medicine like cough syrups are stirred up or shaken respectively before they are used. Why? Because if you don't shake them, most of the medicinal particles didn't dissolve well in the bottle or in the solution that is in the bottle. Okay, so if you don't shake it well, the some of the medicinal particles are down there, and you will take in only the solvent. So you have to shake them well to make sure they are evenly distributed all over before you take them. Yeah, that's a very rare situation. So there's a question for you, and I would like you to reply to me in the comment section. So explain what will happen if a beaker does not mix the dough well, even well enough before shaking. Okay, and two, a mason does not mix the concrete thoroughly before he casts it. What will happen? And if a painter does not mix the paint before he or she uses it, what will also happen? Okay, so this brings us to the end of our lecture today. This is Legend in Learning channel or Legend in Learning class, digital class. Okay, so don't forget to subscribe and hit the notification button for more videos. Okay, so this brings us to the end.